Good evening. So I had some challenges with the network, and I guess now everything is okay. So wherever you are, please be able to join us. Join us wherever you are. Make sure you invite your friends to be part of this live broadcast. Yes, let us see how we can help each other. These are some of the important topics, or one of the important topics that you're going to encounter in an exam. Let us learn together, and of course I'll try by all means to simplify everything so that at least even as you at the end of the lesson you should be able to pick something. That is my objective. So please do join us wherever you are. Let us learn together. And most of the people are sleeping. It's just 22. And you're not supposed to sleep at this time if you're writing an exam. So if you're writing an exam, sleeping 22 hours is quite dangerous. Okay, so there's one who is watching. So please be able to confirm. Just type in the comment and be able to communicate if you're able to get me to your end so that we can start. Others I know will find the recordings. So please just comment in. Am I audible to your end? Can we start? Okay, we can just start. And of course, just look at the information there. Okay, so let us start and see as we go on. I'm sure others will be able to join. Okay, so to start with, we offer intensive online tuitions or lessons in the following subjects, that is mathematics, physics, be it pure or physical, chemistry, pure or physical, biology, and of course civic education. If you are interested to join us, do call me on the number 0976 402563. You can WhatsApp me on the same number if you want to join us. So I encourage even those, so who can join. So one, those who are writing GCE, you join us. Those that are writing internal, it is the right time even you to join us. Even those that are in grade 10, starting grade 10 up to 12, and of course those are writing GCE, be able to join us, okay, as we embark on this journey. Or what we want at the end, our objective as an online platform is to offer the best online tuitions, okay? So please, if you are interested to join, you can communicate through these details. And of course the charges are 80 kwacha per subject, okay? Physics, chemistry, all these are counted separate. It's not science. So 80 kwacha per subject, then you'll be added. We use Telegram for online learning. Okay, so let us look at the main business for today, and that is atomic physics. Okay, so what do you need to know about this atomic physics? So the first thing, or the first part of this atomic physics, is what we call the nuclear atom. So basically this first part, if you've done atomic structure in chemistry, then you have no problem, because the first part, that is the only thing that is there. So just describing what an atom is. Okay, so the first thing that we can do is defining what an atom, and of course we can say an atom is the smallest, is a smallest particle of an element that take part in chemical reaction. That is an atom. Okay, so an atom is just the smallest particle of an element that take part in a chemical reaction. Now, in terms of structure, let me draw in terms of structure. Generally, an atom is made up of subatomic particles. Although it's the smallest particle, it has even smaller particle inside, and these are called subatomic particles. Knowing that you have the basics from chemistry, so I'm going to draw the structure of an atom. So this one is the what? The structure of what? An atom. Terms that we can that are very important in our study. What are the terms? One, atomic atomic number. So one of the terms that you are going to come across is atomic number. Okay, then the other one is the nucleon number. Now in chemistry, commonly we use mass number. So for you to know, mass number and nucleon number is just one and the same. Then what is the other one that we are going to find? We are going to find neutron number. Okay, so these are the terms that you shouldn't miss. Okay, now we have the atomic number, nucleon number, and of course neutron number. Now these, in terms of atomic number, the definition is that the atomic number is just a sum of all the atoms in the nucleus of an atom. I mean the sum of all protons in the nucleus of an atom. That is what you call atomic number. Atomic number is just a sum. How many of the atoms, how many of the protons, I mean, are there in the nucleus of an atom? That is what you call atomic number. Okay, and it is represented by the letter Z. That is another thing that you should know. Then nucleon number is the mass number, and of course is denoted by the letter A. Then neutron number is N. Okay, now from these three, that is Z, atomic number, A, mass number, and of course N, neutron number, there's a formula that you need to know. That you can use to calculate any of these, and that is the N plus Z equal to A. So this one you need to know it, very important. So N for neutron number, Z for atomic number, then A for mass number. And this means that the nucleus makes up the mass number, because the mass number is simply the sum of the neutrons and the what? The atomic number. Okay? Because these are found in the nucleus. So the whole of this makes up the what? The mass number. That is very important to know. Now, what else can we, or what else is important here? What else is important here? So generally, if you have an atom labeled X, okay, an atom of an element labeled X, here on top what you find is what? A, then here Z. So this is mass number or nucleon number, and this is what? Atomic number. Okay, so the elements that we find on the periodic table, for example, let me give, because this X I've put generally for any atoms that you find, for any elements that you find. So let us say we have the element calcium. Calcium, if you check on the periodic table, you find on top there's 40, then down here there's 20. Be able to confirm this. What it means is that this top part of calcium, 40, is the mass number, and this down part is the atomic number. That is what it means. The other one is the magnesium, Mg. Magnesium, here you have 24, here you have 12. So 24 is the mass number, and of course 12 is the atomic number. Okay? So that is something that you should know. So basically, that is something that you should know about an atom, that is nuclear atom. What is something that you need to know? How to define an atom, although it might not be that important in physics, but we don't know what happens. So an atom is just the smallest particle of an element that take part in chemical reaction. Now, an atom has smaller subunit within it, that is the proton, the the neutrons, and of course the electrons. The neutrons and the protons are found in the nucleus, and the number or the sum of these two is called the mass number. By the way, if you didn't define what the mass number is, it's just the sum of the protons and the neutrons in the nucleus of an atom. That is the mass number. Then electrons are found around the shells, and they are negatively charged. Overall, the nucleus is positively charged. If you have an element represented X, that generally the number on top here is the mass number, then the down here is the atomic number. So for example, calcium, 40 is the mass number, 20 is the atomic number. Magnesium, 24 is the mass number, then 12 is the atomic number. Now, what is the importance of learning even about this? This is just to introduce something. This is just to introduce the interesting part of this topic, or maybe let me say the major part of this topic, because this is chemistry. So to connect it to physics, to understand another part of physics, which is called radioactivity, we have to go through this part. Now, before we go to looking at radioactivity, let us look at the concept of an isotope. Okay, let us look at the concept of what? Isotope. Now, as the name suggests, what do you think are isotopes? What do you think are isotopes? So isotopes, we are just looking at atoms of same elements. Atoms of same elements having same atomic number but different mass or neutron number. That is how we simply define an isotope. So which means some elements, they do not exist as just one or single atom. Instead, they exist as two or more. Okay, so an isotope is just atoms of same elements having same atomic number but different mass number. For example, carbon, there's carbon 12, carbon 13, and of course carbon 14. Now, in physics, you're going to find it is written as dash, like this. Okay, so when you find an element written carbon dash 12, it means this is the mass number. And you know the symbol for carbon is C, so the mass number 12, C, the mass number 13, C, the mass number 14. But the atomic number is the same. In all the cases, the atomic number of carbon is 6. So you see now, these are isotopes because they have same atomic number but different neutron number. Different neutron number or mass number, because what determines the mass number is the neutron and of course the atomic. Okay? So if the atomic number is the same, neutron is changing or neutron number is changing. Equally, even the mass number changes. So mass number and neutron number, that is how you look at it. That is an example. Okay. Now, the other thing that you should know before we come to the concept of radioactivity is that among these isotopes, the most stable isotope is carbon 12. And you've seen in most of the calculation, carbon-12 is used as a reference because it's the most stable of the three. Now, these other isotopes are not stable. They are not stable, and therefore for them to be stable, they disintegrate. Okay? And that is what we are going to look at now, the concept of radioactivity, because in the whole topic we are going to look at, starting radioactivity, we'll look at how isotopes disintegrate or decay in order for them to attain stability because they are not stable. Okay, so as they disintegrate, they emit some radiations. Okay, so away from this part, let us look at now radioactivity. Okay, so the first part of the topic is just atomic structure, and of course I've given a brief introduction to that, and I guess we are okay to proceed now to look at the part that is ahead. Okay, so please just confirm you are following. Just type in the comment section, confirm if you are following, so that we can proceed to look at radioactivity. Alright, so let us start radioactivity. So this is something new that you are coming across for the first time. Otherwise, atomic structure is something that you know. So what is radioactivity? So in short, you can define it as the emission of radiation by the radioactive substance. That is what we call radioactivity. And of course, like we said, isotopes, some isotopes are not stable, and therefore them to gain stability, they do what? They decay by emitting what? Radiations. Okay, so that is what happens. So radioactivity is simply the emission of radiation by the radioactive substance or by a substance. Okay, so isotopes, what you should know, that they are not stable, they are unstable, which means that their nucleus disintegrate. To disintegrate, please, is just to decay. So they disintegrate easily. When an atom decays, you know what happens. It radiates, or it produces what we call nuclear radiation. Okay, so we can say unstable isotopes decay to emit nuclear radiation. Okay, to emit nuclear radiation. Now, what is nuclear radiation? So nuclear radiation, we are just looking at particles or waves that radiate from the nucleus. Okay, so nuclear radiation, we are just looking at particles or waves, or wave, particles or wave that radiate from the nucleus. Okay, that is what we call nuclear radiation. Now let us look at the types of these nuclear radiation, types of nuclear radiation. What are they? What are the particles or waves that are produced when the nucleus of unstable isotope decay? So there are three types, of which two of them are particles, then one is a wave. And this is why we said on nuclear radiation, you say these are particles, carefully, wave, that radiate from the nucleus or unstable isotopes. So please, basically here, one thing you should understand is that we are looking at the whole concept of isotopes. So, like I said, the key point or the key points that you need to take note that isotopes, we are looking at atoms of a small, atoms of the same element having same atomic number but different mass number. Isotopes, some isotopes, are unstable. Now, for them to be stable, they release or they decay, their nucleus decay. And of course, when the nucleus decay, it emits some radiation called the nuclear radiation, and that helps it to be what? To be stable. And as we are going to see what really happened, let us look at the types of radiation before we come even to that part. So the types of nuclear radiation that are produced, I said two are particles, of which the first one that is emitted is called the alpha particle. So the alpha particle is the one that is emitted first. Otherwise, you can write it like this. So alpha particle or alpha radiation. Then the other one is called the beta particle. Okay? Otherwise represented like this. Beta particle. Then now, there is also what we call gamma radiation. Gamma radiation. So this one is the wave. It's an electromagnetic wave. Electromagnetic waves. And I guess you've done electromagnetic waves, that is after light there. Okay? So these are the particles that are produced. So up to this point, what we've learned so far, questions, we can find questions in an exam. Okay? Up to this point, All right, let us look at now these particles that are produced. So for the particles that are produced, particles and waves that are produced, one thing again that we can say, when they are produced, energy is also produced. Okay? The emission of these also, energy is emitted. Now, what is something that is important to know about these particles that are emitted? That is the alpha. Let me just write them here. Alpha, beta, and of course gamma. Let me just write them here. These. Okay? So when they are emitted, what is the general, because we are saying when they are emitted, they cause, in short, they cause the original atom or element into, produces a new or a daughter. Okay? It produces a new, it results into the nuclide of the original unstable isotope. When it decays, what happens? It results into what we call a daughter nuclide. Okay? And that is what we call transmutation. So transmutation is just the changing of one element into another one by radioactive decay to form a daughter nuclide from the parent nuclide. So this is what it means. Let me just find an example that we can look at. So we are going to start by looking at alpha. So not to worry, they are general. Okay. So we'll start with alpha. So what happens when an atom decays by emitting an alpha? What happens when it decays by emitting an alpha? So when an atom decays by emitting an alpha particle, the mass number reduces. So mass number reduces by 4. and the atomic number and atomic number reduces by 2. Okay, so this is what happens when an atom decay. So we are looking at decaying. We said when an atom decay can either produce alpha, beta, or gamma. Now when an atom decay by emitting what? An alpha, the mass number reduces by 4 and the atomic number by 2. And of course now it forms a helium-like atom, and that is what we call an alpha particle. So in terms of definition, an alpha particle is a helium-like, or let me just say it's a helium atom, and you see soon what it means. So generally, the equation when an atom decay by producing an alpha particle, let's say an atom is X, the mass number is A, and of course the atomic number is what? Is Z. Then you are going to put an arrow. So generally the atomic number we said reduces by 4. The mass number reduces by 4, the atomic number reduces by 2. And of course you are going to result into the new atom, which is called the daughter nuclide, plus helium. So this one is always, if it produces an alpha, this is what you are going to write in terms of if you are asked to write the equation. Okay, so this one is called the parent nuclide. Through the process of transmutation, it results into, this one is called the what? The daughter nuclide. Okay, and this one is called alpha particle. Now here, let me explain the questions that you expect. One question that you expect, you might be asked the question, what is the atomic number for the alpha particle? What is the atomic number for the alpha particle? You know that the alpha particle is this one, so the atomic number is simply 2. Okay, so the atomic number is simply 2. Now let me give an example. So let me say uranium U with atomic number of 92 and mass number of 238, decay by emitting an alpha particle. Okay, what is the question? State the meaning of the term nucleon number. So state the meaning of the term nucleon number. If that was the first question, nucleon number, what did we say? Nucleon number is just the same as the mass number. So nucleon number is a sum of protons and neutrons or neutrons in the nucleus of an atom. So that is what the question requires you to. If you are asked to if you're asked to state the meaning of a nucleon number, so that is how you look at it. So nucleon number is just a sum of protons and of course neutrons in the nucleus of an atom. Okay, then what is the other question? The other question that you expect is that what is the proton number of an alpha particle? What is the proton number of an alpha particle? So I explained already on how to determine the proton number of an alpha particle. I said an alpha particle is just a helium particle. So a helium particle, even in this one, you know that if they tell you that decay by producing an alpha particle or decay by emitting an alpha particle, just know that there is a helium atom. And of course the helium atom, the atomic number is 2. So you should know that. So the atomic number is 2. Then the other question that you might expect is, state the proton number of, so now, listen very carefully here. So they will tell you, and of course the symbols will be given. Okay, I should have included the questions here, but not to worry. So let us try to modify this question. Uranium, you decay by emitting an alpha particle. Okay, so uranium initially has the mass number, so without even being told, let's say, okay, has atomic number of 92 and of course the mass number of 238, decay by emitting an alpha particle, and the resulting what? The resulting daughter nuclide is thorium, Th. If at all that is what you are taught, that the resulting is what? Thorium. Okay, Th. Let me say, then you are told to write the decay equation. You are told to write the decay equation. I think this is something that I have to explain now. You are told to write the decay equation. How do you do it? So you are going to follow this one. So this one being the original, which is the uranium, and uranium we can put the mass number is 238. Then the atomic number is 292. 92. So that is how you write it. When it decays by emitting an alpha particle, it's going to result in 2. We are given the symbol of thorium, which is Th. Then now, what happened to the mass number? Look at this. The mass number is going to reduce by 4. So 4 minus 238. You're going to have 234. Then this one is going to reduce by 2. Okay, I say it reduces by 2. The atomic number reduces by 2, therefore it remains 90. Then plus, don't forget the helium, the alpha particle, which is the helium atom. Okay, and of course this process produces also energy. So this is the decay equation using this general one. So if you are told that it emitted an alpha particle, that is how you write it. So the one that emitted an alpha particle, that is how you present it. Now, from this question, that is where all those questions that I was asking, such as what is the atomic number for the alpha particle? So this is an alpha particle. So what is the atomic number? You just look at this one, it's 2. What is the mass number? 4. Okay. Now the other question that you are asked is that what is the proton number for the what? For the what is the proton number for the new? For the what is the proton number of thorium, or for the daughter nuclide? So either you specify the thorium, or they just tell you the daughter. You know the daughter is what is produced. Okay. So what is the atomic number? The atomic number is 90, and its mass number is what? 234. So how have we arrived at this 234? The general equation is that when it decays by emitting an alpha particle, the mass number reduces by what? By 4, and the atomic number reduces by 2, and of course you have the resulting. Now listen very carefully. Here you know that on the periodic table, elements are arranged according to the increase in atomic number. Okay, so we have this element here. If it has atomic number 2, the next one will have atomic number 3, the next one will have 4, the next one will have 5. This is how they are arranged on the periodic table. Now if you are subtracting the atomic number, let's say 238 is here, of course the next one will be 239, 234, 239, 240, 241. So as you are doing this, you are subtracting 4, which means you are moving 4 steps backward, and that is your resulting nuclide. Okay, just trying to look at, so thorium is behind uranium. Uranium is way ahead, 4 steps ahead of thorium. Then now if you are looking at what you want to find as your daughter nuclide, you just look at how many steps. No, in terms of sorry, we are talking of in terms of atomic number, so it has 2 steps backward, not 4 steps. 4 steps is mass number. Mass number really not a pattern that is followed, but the atomic number. So it means that 2 steps backward. Okay, that is your resulting. But not to worry, because normally here you are given the resulting daughter, and of course its symbol. So not to worry, but in the case you have to find it, you need to move 2 steps backward. That is how you trace it. Okay, I guess that point was clear. So now that is another question. That is one question that you expect, or the questions that you've looked at, that is what you expect in terms of alpha. Okay, so when it decays, the point to take home here is that when an atom decays by emitting a or an alpha, the mass number reduces. The mass number reduces by 4, the atomic number by 2. Now let us look at also what about beta. So when it decay by beta, what happened? When it decay by emitting beta, what happened? So for this, the mass number remains the same. Atomic number increase by 1. So mass number remains the same, but atomic number increases by what? By 1. Okay, so general equation is when you have an atom with mass number and atomic number decay by emitting a beta particle, it is going to be mass number the same, but atomic number will increase by 1, then the resulting. But you need to know that a beta particle is a fast moving electron with mass number 0 and of course a charge of -1. Okay, so that is the equation. Now why does the mass number remains the same and of course the atomic number increases by 1? Wow, what happened is that during beta decay, a neutron of an atom split. Okay, so a neutron split into an electron and of course what? A proton. Okay, split into an electron and a proton. So let's say for example you have an element with atomic number of, let me put 20. Then let me put this one, let me give a comprehensive. Okay, so I'll give phosphorus 32. Is it phosphorus 32? Then I'll put 15 here. So what is the number of protons in this atom? What is the number of protons? So number of protons, number of electrons, number of neutrons, I mean, you have A is equals to Z plus N. I guess you remember this formula. So what we have is Z, which is 15, and A, which is 32. Now I want to find the neutron. So number of neutron, you find that is 17. So you have 17 neutron in this one. I want to explain how the beta particle comes about. So one of the neutron out of 17, you are remaining with 6. It's split into 2. Okay? When this split into 2, one will be what? Electron. Then one will be what? One will be a proton. You see now? The number of neutron has reduced to 16, but the number of proton has gone to 16 because initially it was 15. So when this one split, it becomes what? 16. So you have 16 number of protons, 16 number of what? Neutron. If we were to add this, what are they going to give? The original mass number of 16, which is 32, which is this one. So that's why the mass number does not reduce, because of the neutron that split into proton and of course what? Electron. Now this electron is one that is emitted as a fast moving electron, and that is what we call the beta particle. So the beta particle is just a fast moving electron, okay, with a mass number 0 and of course the negative charge. This is not an electron, and this is the what? A beta particle. So that is something that you should know, okay. So let's say, for example, the same phosphorus 32 decayed by emitting what? A beta particle. Decayed by emitting a beta particle. Okay? So phosphorus 32 decayed by emitting what? This one. Just giving an example, yeah? Just in terms of numbers, what is important, I want you to understand the numbers. So the mass number remains the same, but the atomic number will increase by what? Will increase by 1, and this one is going to be 16. Now, plus an electron with mass number 0 and negative 1 charge. So now, no, this one is not going to be phosphorus. What will be the resulting daughter here? Will be the resulting? Now, in terms of alpha, we said you move 2 steps backward. But this one, look at this, the atomic number is 15. This one has increased to 16. So you move 1 step forward. And if you move 1 step forward, if you have a periodic table, if you want to check, 1 step forward of phosphorus should be sulfur. So it will result into sulfur. Like I said, these will be given. These I'm just using in terms of, for the sake of explaining. These resulting nuclide will be given in most cases, but if you're not given, that is what you do. So you just look at the one that is 1 step ahead, the one that is next to phosphorus ahead, the one that has, in short, mass number 32, and of course the atomic number 16, okay, should be sulfur. So that is the daughter, and of course this is the equation for beta decay. So what is the take home point here? When it decay by beta, mass number remains the same, the atomic number reduces by what? Increases by 1. And what happened behind is that the neutron, one neutron split into electron and proton, and of course the electron is the one that is emitted as a beta particle, okay. Then up next to gamma. Gamma is a radiation. So this one is the electromagnetic radiation. So generally nothing changes, mass number remains the same, atomic number remains the same, but huge amount of energy is produced. So for example, if you have X, A, Z plus what? O, it decays by emitting a gamma. It is going to be X with mass number the same, and of course Z, then plus a gamma with mass number 0, charge 0, okay. Then what is going to happen? Plus what? Plus energy, okay. So let me just put it like this. So this is the symbol for gamma radiation. I should have indicated here, gamma radiation, then plus energy. So that is the general one. So for phosphorus, if we were to decay by emitting a gamma radiation, it will be P32, 15, P32, 15 plus gamma radiation plus energy. Okay, that is how it was going to be. But listen please, it is not every time that only one is emitted. Sometimes one can be emitted after another. It is very possible that one atom can emit a beta particle, then, or I mean alpha particle, then a beta particle, or two beta particles. So if it emits two beta particles, which means what will happen? You write a 2 here, then plus, which means this atomic number will increase by 2. Okay? Have you gotten that? These 2 you put in front of, showing that 2 beta particles have been emitted. And of course, this one will increase by 2 because 2 of the beta particles have been emitted. So that is how we basically look at it. Okay? Well, someone is saying volume increase. Okay, so please, for the remaining part, we can meet in the next one. Otherwise, we need to answer some questions. Perhaps tomorrow morning we can meet to answer some questions, but tomorrow we can do another subject, please. So we'll reserve the remaining part for the other day. We'll see tomorrow how it goes, if we can chance or find a chance to still go through. Okay, so today we can end here.